Okay, welcome to lesson 155 of Algebraic Concepts, or 2155 overall. This is the last in a series dealing with exponential functions, rational functions, radical functions, graphing them. So let's get into it. All right, so here's our objective. Here's our vocabulary, so please read through that. We're going to get an interest rate problem, and this is how credit cards are run. Here's the formula. Okay, so when dealing with a case like this, there is a formula out there that says, and I did not put it in the picture. So y, we had in the last video, y equals a times b to the x power. But there's also another formula that says y equals some number times 1 plus some other number b to the x power. Okay, so if we take our a as 10, because that was the first number given, $10, and then we do 1 plus 0.04, because the value is going up. 1 would be 100%, and then 4% is 0.04. So it does not, we can't multiply by 0.04. That is the interest, but it's going up. So imagine taking 100% of your item and then increasing it by the 4%. That's why we had to do 1 plus 0.04, and then it was only for 1 year. So this is what we have. And so we have 10 times 1.04, which is 1040. So after a year, your coin will be worth $10.40. But let's try 20 years. If I had y equals 10 times 1.04 to the 20th power, it might look a little different. So let's put that into the calculator. We're not graphing it this time. And you type it just like it's written. 10 parentheses 1.04, close the parentheses, caret 20, and then hit enter, and you get 21.91. So a $10 investment would double in 20 years. That may not seem like much, but if you had $100, or the more money you have, the more money it would go up. It would increase by. So that is that type of problem. Okay, so let's deal with a colony or some kind of exponential growth, dealing with bacteria. Bacterial growth. Same concept here. Y equals a times b to the x power. Our a is 1,000. We're talking about an increase, so we're talking about 1 plus 0.32. And what's our time? Each day. And we went 7 days. So we just stick our numbers in, and this is what we get. Sticking it in just like it's written will give us So 1,000 bacteria will go up 6 times in 7 days. Okay, so let's look at our third investment. Okay. 20 years, $600 compounded monthly at 10%, or 6,000 compounded semi-annually at 0.02%. Which one is more and how much more is it? So I am going to do the first one with all the numbers in black, and the second one, here's our principal, here's our interest rate, here's our time. This is years and this is months. So you're going to have to convert this one to years, which is 1 over 12. Each month is 1 over 12. Semi-annually is half a year. So let's convert those to years, and then we can move on. All right, so first one is in black. Our formula, A equals the principal, the original amount, 1 plus little r over n to the n times time. And so what we have, oh, this is a typo. This should be 6,000. I apologize for that. All right. So our principal is 6,000. 1 plus our R is the percentage or rate, which is 0.10 after you divide 10 by 100. Our 12 is our number of times. And then 12, because it's compounded monthly, is 12 months in a year, times 20. Okay, so when I put all of this into the calculator, we get 43,933 and 56. Okay, so that's for the 10% compounded monthly. So let's look at the semi-annual compounded. All right, same formula, 6,000, 1 plus the rate. What was that, 10.2%? 10.2 is our rate. Our number of times is 2 times a year. And then 2 times 20. And when we calculate that out, we get 43,879 and 32. And as you can see, the one compounded monthly gives you a slightly better return. It's not as much as you think it would be, but if we subtract them, we get 56 minus 32 is 24. 13 minus 9 is 4. 12 minus 7 is 5. So it's better by 54.24 over 20 years. If you have $6,000 to put away, put it away into an account like this, either compounded monthly or semi-annually. But this is how investments work. The longer they're in there, the better off you do. And you can see you more than doubled your money in the 20 years. So these were our examples. So I showed you how to use the formulas. Please work on the practice problems on a different sheet of paper, and I'll see you at the end of the video for a recap. Okay. Every time Helen washes her wool blanket, it shrinks 2%. So this is decrease. So this is going to be 1 minus 2%. If it was 92 by 102 inches when it was new, what will the dimensions be to the nearest inch after it's washed 6 times? Okay, so let's deal with the 92 side. We're going to have 2 separate equations here. So I'm going to do this one in black and 102 inches in blue. So we get y equals, our original amount was 92. We're doing 100% minus 2%. And raised to the 6th power because it was washed 6 times. And that will approximate out to 81 inches. You'll get some decimals, and I should have probably put them down, but I'm just rounding this off to the whole number. So the 92 side shrunk down to 81. What about the 102 side? So y equals 102. Because this is shrinkage, we're doing 1 minus 0.02. All to the 6th power, and this is about 90 inches. It's a little bit more, but it's close enough. We're dealing with whole numbers, and so that's what we want to stick to. Okay, now, compound interest. Let's deal with the compound interest problem, because you have to see how this thing works. And I'm sorry I did not. This should have been an example. All right, so here's our investments, 5%, compounded annually in 18 years. All right, so here we go. 3,000. I'm using A equals the principal 1 plus the rate over the number of compounds, times the time. So, 3,000, 1 plus our rate, which is 0.05, divided by 18 times, oh no, wait, it was 1, I'm sorry. 18 was the, this is 1, this bottom is 1, because it's compounded annually. That's the number of compounds, so that's 1. And up here is 1 for the compound, that's our N, and the T is 18 years. Okay, so that looks a little bit different. All right, now if I put it in the calculator like it's written, I wanted to use some parentheses. And I get 7219.86. Okay, so how much will Sam owe? All right, so what do we have here? This is our principal. 6 months is 1/2 a year, so we're going to convert that over to 1/2. Compound it monthly. So our N is 12, and our rate is 18.5, so 0.185. Okay, so A equals P, 1 plus R over N, and N raised to the NT power. Okay, so plug in our principal, which is 1,000, 1 plus our rate, which is 0.185, all over our time is compounded monthly, and then 12 times 1/2. And plugging all of that in, we get $1,096.14. So if Sam borrows $1,000 in 6 months, he'll owe almost $1,100. Okay, so now this is declining, so be careful with this one. So we have y equals, this is not a bank loan, so we don't have to worry about it. So you got your principal, 270, or your initial amount, 1 minus 0.12. And then you raise that to the time power, 10. And what you get is about 75. So if you start with 270 lizards, in 10 years, you'll be down to 75. And that's why they say be careful with the environment, because you could destroy species. And those were our problems for this lesson. I think this is the last lesson. I know this is the last lesson in the series. This should be the last lesson in algebra. So Algebra 1 should cover all of these topics. You may not get all of them. I may have went past the Algebra 1 curriculum, and that's okay. It doesn't matter. These courses are set by human beings due to their limited knowledge of things. So if you're able to work and able to work on your own independently, just keep on doing problems. Just keep doing problems and read and try to figure it out and try problems. And the more you do, the better you'll get. And you can go past whatever you are being taught in a classroom. So as long as you have the books and a curious mind and a willingness to try, just keep on trying to solve problems, looking at the examples in the book and working on the practice problems, looking at the answers in the back. And sometimes you're going to need the answer because you're going to make mistakes. And so you just work your way from the answer backwards. You know, that's how you do it. If you don't have a worked out solution, you get the answer and then you figure out and you keep trying different things until you get to the answer. And sometimes that's better than just working alone. So I wish you well. And for those of you with curious minds, so just sit around and just do some math problems and just keep working at it, and you will get better at it. So thank you for watching these videos. And the next video you will see will be coming up will be deal with geometry. So I got to start working on the geometry problems. And then I'm going to move into data, statistics, and probability. And then I'm going to work into algebra 2. And I'll probably keep on working until I get into calculus. But there are tons of teachers with all of these videos out there. So I'm just one person in the bucket. And if you don't find that these or my style works for you, try another one. But just keep on trying. I wish you all good fortune, and I hope to see you on another video or a series of videos.